have around 1 hour before breakfast, and I wanted to get some work done before that happens. Yesterday, I was on chapter 1.4. I really need a bookmark on this somehow. Does this save bookmarks? No. Um, oh, it's already here. It's already here. Okay. So today we're still on number 1. We are kind of behind, not gonna lie. I remade the plan, so it's actually day 1, 2, 3, 4, 5, 6. Okay. So we're gonna do 1.4 today. Well, I'm gonna make some progress on it. I don't think I can finish it today because I have church. But yeah. Okay, let's pull up this part. Program execution time measured in seconds per program. Basically saying time is a measure of performance. A computer program is measuring time per program. Execution time per program includes execution time includes disk accesses. Where is it? It's literally total duration of a computer takes to complete a specific task. It includes everything, CPU time. Okay, why am I still getting notifications? Even though do not disturb. Okay. It includes The disk accesses memory accesses I/O operating system overhead. So there's a lot. Yeah, this is the part I don't get. The CPU time only counts the time processor is actively working on the task. So what does that not include? I want to search that. So it said that the CPU execution time does not only includes the time that the processor actually executes things. What does it not include? Waiting for I/O. So this is like what? Reading from files? Simplest examples of I/O. Reading from files, right? Reading from memory. Uh, when you read from RAM, is that considered I/O? Probably not, right? RAM is separate. It's not I/O. Yeah, I/O is more like files. What I'm confused about though is like isn't it aren't files stored in RAM? I'm confused. Okay, so I/O, opening a file is an I/O, but then RAMs are stored in, or files are stored in RAM, no? Files are generally not permanently stored in RAM. So are they only stored in, like when you do, and your memory. Uh, it only enters RAM when you call a method like read. Oh, the OS literally copies chunks of data from the slow storage bus to the fast memory bus. So that's why it's called I/O. What about files already in RAM? they get replaced, no? Professional environment, these are called RAM disks. Same syntax you do still use with open for these. It's still IO. Alright, so it's waiting for IO. It's not CPU time. Waiting for other programs. Okay, I want to answer why this is important then. That's the main concept that I don't get right now. Why is it important to isolate CPU time? Well, I guess it's because there's my reason, my logical reasoning is that it's very noisy to include everything in execution. Well, execution time includes everything. It's harder to isolate and improve some part of your program if we included everything. When you're trying to improve the performance of something, it's usually better to just improve one part or like focus on another part. That's my reasoning, but I don't really know. That's my reasoning. My logical reasoning. It's very important that I get these right, or try to get these right. These terms mean the total time to complete a task. Yeah, computers are often shared though. A processor may work on several programs simultaneously. Oh, is that like saying that, okay, you can run like this particular script, like a C++ script, meaning our C++ script could be running. I'm trying to guess why this isolation of CP time execution. Mm, Yeah, I didn't really get this point yesterday. So it removes scheduling I/O noise, improves reproducibility. Yeah. Yeah, you can compare algorithms independent of the background load. Helps profiling, find hot CPU bound code paths. What does that mean? Dynamic analysis that measures a software application's performance. It helps developers identify performance bottlenecks, hotspots. Oh, interesting. Helps find the bottlenecks. Yeah. Yeah. Wow. Wait, cold is like when CP the caches are empty, right? Yeah. Hyper-threading contention, different scheduler priorities. Wall versus CPU time using shell time. Whoa, you can do that? Holy crap. You can actually. Oh my god, it's March 1st. I didn't realize that. Kind of random. Wall seconds greater than or equal to CPU seconds. Sleep 4 increases wall time, but not CPU time. More precise CPU accounting. Get our usage on Unix to get user and system CPU time separately. Practical advice for benchmarking. Okay, this is getting too much. This is getting into areas I don't really haven't read yet. So let's actually read this now. Computers are often shared. Processor may work on several programs simultaneously. System may try to optimize throughput rather than attempt to minimize the elapsed time for one program. Yeah, another reason is throughput versus elapsed time. Wait, no. Elapsed time versus CPU time. Well, that's the point. To recognize distinction. CPU time not include the time spent waiting for I/O or running other programs. Will this depend? This will not depend on the program itself, right? Everything that was abstracted ign is ignored with CPU time are all those factors external to the program we are interested in its performance with. Other words, for pure program performance, do we only care about the CPU time? Anything that was ignored, do they not count towards the program? I have to poo.